homework for section 2.5, there's a couple things I want to show you. So number one, let's just look at what's going on. It says, describe how the given function can be obtained from one of the basic graphs, then graph that function, okay? So the first thing we have to realize is that what is the parent function that on this problem?
Square rooting.
Not square rooting, squaring, right? Oh. So notice it's okay. Notice A through D, they have that like first blank. They want you to type the parent function x squared into there. But before we have to do that, we have to pick, is it going to be A, B, C, or D based on our shifting, right? So what's the +2 on the inside of that parent function doing?
Shifting it to the left.
You got it. So what are we going to do? A, thank you. I have a hard time seeing this stuff. Okay, so you're going to just hit X. If you use the caret button on your keyboard, it'll do that exponent for you, and we'll just check that that's correct. And then this is what I was talking about during the lecture. So I'm going to click to enlarge the graph. When you do it, notice you have these tools over here on the right. So notice this is the absolute value, this is the quadratic, and this is the cubic function, right? So the x squared function is which one? This parabola. And we know that all we're doing is shifting it 2 units to the left, correct? So I'm going to grab him, and I know I'm normally at 0, 0, but what do I have to do? Go 2 units to the left. And you plot him, done. Oh, nope, sorry. All right, clear. He did not go. It might not be what I thought it was. That's why. Okay, so I'm going to do that, and I'm going to try to graph him here. And if not, I think okay. So notice this is not what I thought. I thought it was like my algebra class. So notice it just has horizontal shifts, and we want to just put horizontal shift 2 units. Do you see that? You just slide it over. And you go to -2, so you know that it's moving it to the left. Is that okay? And then it's like easier than I thought it was going to be, because the one in our intermediate algebra, you have to click where the vertex is, and then you have to choose one other point on the graph. This one graphs the whole thing for you. You just have to say where it needs to go. And let's just check it. Yay! Okay. So then the other one I was going to look at was number 5. So this is kind of the same thing. We are describing how the graph of g of x equals 1/2 x to the third plus 5 can be obtained from the normal graph of x to the third. We're going to graph the function first. So let's first of all say, how can the graph of 1/2 x to the third plus 5 be obtained from the graph? Well, remember you work from the inside out. So the closest thing is that 1/2, and that's stretching it or shrinking it. Well, if you look at your notes, the vertical stuff is exactly what you think. So if we're multiplying by 1/2, do you think that's going to stretch it, or is that going to shrink it? It's going to shrink it, because 1/2 is small. It's a fraction. Oh, okay. And that's what, like, it's hard to remember that. But if you look at your notes, and page 3, I don't have them labeled, but it shrinks it if the absolute value is between 0 and 1. And 1/2 is between 0 and 1, correct? So anytime it's a fraction less than 1, it's going to be a vertical shrink, okay? And then what's the +5 on the end doing, guys? It's going to go up 5. So we're shrinking vertically and going up 5. Is that D? Is that right? Shrink vertically and shift up 5 units. Yay! Okay, and then I believe it's going to be the same kind of idea where we're going to pick the cubic function this time. So remember, the cubic's your snake, and you just plot the origin, I guess, right? And so what we're going to do is we're going to vertically stretch it by typing 1/2. And then we're going to, what else were we doing? Shifting it up 5. So a vertical shift up 5. Does that look okay? You guys see what I did? So I typed it. I believe I can try this. Let me do 1 divided by 2 and see if it'll take that as well. Okay, so it does. So you can do 1/3 and stuff like that. And then notice I did a vertical shift of 5. So it should be stretched out and then moved up. I'm going to hit save and cross my fingers that I did it correctly. I did. Okay. And then what's the last one I wanted to show you? Number 10, I think I had on there.
No, just one. Oh, yeah, 10.
Something like number 10. And so we'll just do it. That's fine. Okay, so it says the point -16.8 is on the graph of our normal function f of x. Find the corresponding point in the graph g of x if g of x is 2 times f of x. And all this is making you realize is that we have our normal function here, but that 2 on the outside is doing what? Well, since it's on the outside, it's something vertically, right? And when it's on the outside, it's exactly what you think. So what operation is that 2 out in front doing? You're stretching it. And literally, if you look at your notes on page 4, whenever you have an a out in front, what are we supposed to do? We're just supposed to multiply our y coordinate by that a, right? We're stretching it out. So we're going to have our normal function, f of x, but then to each of those y values, what am I going to do? Multiply them by 2. So if this point is on the graph, negative 16, 8, what am I going to do? I'm going to take its y value of 8 and multiply it by 2. So what's my new y value? 16. Did I do anything to the x? No, because the 2 is on the outside. So what's my coordinate going to be? Negative 16. But what's my new y coordinate? 16. You see that? So it's very hard because it's generic, right? It's not giving you like x cubed plus 8 or anything like that. All it's saying is that when you have a 2 out on the outside of your function, that means you're multiplying each of your y values by 2. You're doubling each of your y values. So since this graph was at a y value of 8, I doubled it to get 16.